So far we've looked at examples where you get given displacement as a function of time. In this example we've got velocity as a function of time. So this function tells us for a given value of t, what is v equal to. So let's have a look at part A. So in part A we're asked to find the initial velocity. So we need to remember that this word initial means what happens when t equals 0. What's the velocity when t equals 0? So let's substitute in when t equals 0. So when t equals 0, we get that the velocity, just substitute in t equals 0 into there and you get 24 meters per second. Okay, in B, we're asked to find the value of t when the body is instantaneously at rest. So that word rest tells us that v equals 0. So we want to find out what times is velocity equals 0. So let's solve that. When v equals 0, we're going to get 0 equals 2t squared minus 16t plus 24. And we could use any method we want to solve this. I'm going to factorise it. But I've noticed that 2 is a factor of each of the terms in this quadratic. So let's divide both sides of this equation by 2. 0 divided by 2 is just 0. And then divide each of the terms on the right hand side by 0 to get a slightly simpler quadratic to factorise. So to factorise this, I'm looking for two numbers that times together to make minus 12, add together to make minus 8. So that's t minus 6 in one bracket and t minus 2 in another bracket. So we get our two solutions, either t equals 6 or we get t equals 2. So they're the two times at which the velocity of the object is equal to 0. Or another way of saying that is it's instantaneously at rest. So it has to find the value of t when the velocity is equal to 64. So this is a straightforward solving an equation. What happens when v equals 64? So let's solve that. When v equals 64, we're going to have 64 equals 2t squared minus 16t plus 24. And this is a quadratic equation. Let's make it look like a quadratic. Let's take away 64 from both sides to get 2t squared minus 16t minus 40. And again, we can use any method we want to solve this. I think I'm going to use a quadratic formula. So I'm going to write down the quadratic formula, but I'm actually going to use my calculator just to solve it. So I'm going to write down the quadratic formula. And I'm going to use my calculator to give me the two values of t. So the two values of t that we get, we're going to get t equals minus 2 or t equals 10. That's my two solutions. Now, as soon as I see a negative value of t, I'm straight away thinking, well, here we're told that t is greater than 0. That's because time generally can't be negative. It's a bit weird to say that time is minus 2 seconds. So I'm just going to explain that. I'm going to say because t is greater than or equal to 0, we get one solution, t equals 10. Just to make it clear that I know that t equals minus 2 isn't a solution. In part D, we're asked for the greatest speed of the body in the interval 0 to 5. We've got to be a little bit careful with speed. Because remember, speed is always a positive number. So it's not necessarily the case that the greatest speed is going to be the greatest velocity. To see that, let's look at two different velocities, for example. If we had a velocity of 5 and another velocity of minus 10, then obviously the velocity of 5 is bigger because 5 is bigger than minus 10. But if we were to compare the speeds, the speed when the velocity is 5 would be 5, and the speed when the velocity is minus 10 would be 10, because we always make the velocity positive when we talk about speed. So actually, the velocity of minus 10 would have the biggest speed when we make it positive. So we've got to bear that in mind when we try and find out what the maximum speed is. So I think the easiest thing to do here is going to be to sketch a graph of this function v to find out what's happening with this graph. So we know that it's got a y-intercept of 24, and we also know the roots because we found the roots in part B. So let's just draw out the axes and see what this graph looks like. So we're going to put t on the horizontal axis, and we've got velocity on the vertical axis. So we know when t equals 0 that the velocity equals 24. And what we'd normally do is we'd solve v equal to 0 to find out what the roots are. But we've already solved v equals 0 in part B. We know that when v equals 0, t equals 6 or t equals 2. So we can put the roots on our graph. We've got 2 there, and we've got 6 there as well. Now we know that this graph is just a straightforward positive quadratic graph, and it's a positive quadratic because we've got a positive coefficient of t squared. So if we sketch this graph, it's going to have that positive quadratic shape. Obviously, hopefully yours looks a bit better than mine, and we're going to have a shape that looks like that. So what we've got to be careful of is it looks like 24 is going to be the biggest velocity because none of these have a bigger velocity. What we've got to be careful of though is what is this turning point? Because for example, if this turning point, and I know that it's not, but imagine if this turning point was minus 30, then even though 24 is the biggest velocity, the speed at this point, at this turning point, would be 30. So this 30 would be the biggest speed because we'd make it positive. So let's actually find out what this turning point is. So the easiest way to find the turning point, we could either use differentiation or we could complete the square. Let's use completing the square to find out what the turning point is of this quadratic. So if we complete the square, we're going to take out a factor of 2 first because we don't like that coefficient of 2, and I'm going to take that outside of a square bracket. So we're going to have t squared minus 8t plus 12 inside the square bracket, and then we just need to complete the square inside that square bracket. So if we do that, we're going to have t minus 4 squared and plus 6, minus 16 and then plus 12. So let's just simplify inside the square bracket. We're going to have t minus 4 squared and minus 4. So in order to find my turning point, I need to multiply out the square bracket. So we're going to have 2 lots of this bracket squared and minus 8 if I times the 2 by the minus 4. So remember that we can find the turning point from this completed square form, the coordinate, and the coordinate of that turning point is going to be 4 minus 8. So let's label that in. It's 4 minus 8 there. So actually we know that the minimum velocity is minus 8. So the speed at this point is 8, and the speed at this point is 24. So 24 is going to be the biggest speed. So we're just going to conclude and write that down. So the maximum speed is 24. Meters per second.